So now we will talk about the NAT, Network Address Translation. We'll understand the NAT technology, what is NAT, and why is it so important in the networking. And we'll go in depth and we'll explore the NAT, its function, and its application in networking. So what is a NAT? NAT is an essential technique in networking that enables the translation of private IP address to public. Means the INA has specified IP addresses into two parts. One is the private IP, another is the public IP. So private IP is what the IP address which is used in the LAN, in the local area network, and public IP is the globally routable addresses. But private IP addresses, they are not globally unique. Means I can give the same IP, that is the private IP, in two places. But I cannot get the public address, the same public address you cannot get in two places. Because public addresses are globally unique. This mechanism allows numerous devices within a local network to effectively share a single public IP address. So definitely it conserves the IP address space and it optimizes the use of the limited IP resources. Now what is NAT? NAT is used to conserve the IP address. Now, if I'm going to communicate from any LAN to outside network, now my private IP will not be understood by the ISP. So how can I communicate? Because I have a big ISP, public address space between me and the destination. So you need to have one that should be translating your private IP to public IP and public to private. Now it would conserve the IP addresses. NAT is a method that enables the conservation of IP addresses by allowing the multiple devices on a local network to utilize a single public IP address. Because you can have the feature of the PAT, that is the port address translation, and you can have only one public address, and then you can have the different private addresses. But those private addresses will be translated to one public IP. Because the public address is limited, that is why you have to use the NAT. Then it enables multiple connections. By transferring the internal IP address to a public address, NAT provides a layer of abstraction or differentiation between the local network and the internet. This technique allows seamless connectivity for multiple devices. Without exposing the individual IP address means that, say, if you're using a web server, file server, any email server, that you cannot just expose your IP address of the server because then anybody could hack it. Now, NAT actually acts as a layer of abstraction. It hides the real IP address. So that is also a job of the NAT. Now, the NAT modifies the packet headers. Yes, because the source IP address is translated in the NAT. So you're using 10.0.0.1 as the source IP of your PC. And when it hits the NAT router, then it takes the public IP address that is there on the serial interface and it modifies the packet header. When a packet is sent from a device, then NAT alters the IP address information in the packet headers, and this modification is performed in real time as packets transit through a NAT device. So it ensures proper routing and connectivity. Now, why use NAT? NAT conserves valuable IP addresses. That is the first thing, because the public IP is limited, that I've already told you. Then it enhances internal security measures like you are hiding your IP infrastructure. Then it simplifies overall network management and facilitates the network reconfiguration. So all these things are advantages of NAT. Now we'll talk about the types of NAT. So what are the types we have? First of all, we have static NAT. Now static NAT provides a one-to-one mapping, which is useful for devices that need a consistent public IP addresses such as web servers or email servers. So if you need those servers, they should have the static mapping because they cannot change their IP address every now and then. So in that case, that should be static NAT. And it ensures that external users can reliably reach the device with the same public address, because we know the public address of the web server. Now, every now and then, if it changes, then it would be difficult. Then you have the dynamic NAT. Dynamic NAT allows for efficient use of public addresses by assigning them from a pool. So if you're talking about a network, if you're talking about a big network, then say 100 devices, then you should have a pool of public addresses of 100 devices. And this is ideal for organizations with a fluctuating number of internet connected devices. But the downside is that you need to have then 100 public address. Now, it is definitely very difficult to buy all of those public addresses. Now you come across the port address translation. That is a reliable method and that is a cheap method. Port address translation, also known as NAT overloading, allows multiple devices on a local network to be mapped to a single public address. So you have a single public address and you're having a lot of private addresses. So you will map that single public address to all those, let's say the 100 or 200 private addresses, and that is cost effective, but uses different ports for each session. So the port number, the source port number varies because with each request, the source port number varies. That is why it is known as port address translation. This maximizes the utilization of available IP address and is commonly used in home networks. So in home network or office networks, we use this PAT. Generally, we do not use the serial, static NAT, and the dynamic NAT. So that is about the theoretical discussion about the NAT, what is the NAT and what are the types of NAT we have. And now I would like to show you the configuring NAT. First, I will configure the static NAT and then we'll configure the dynamic NAT and PAT as well. So let me take you to the packet tracer. So you can see there are two routers and they're connected with the serial port. So let me configure the IP addresses first. Go to the interface. And the serial. Let's say it's 192.168.0.1. And you configure, let's say, OSPF. It should be in area 0. And then go to router 1. Twenty zero zero one, that's IP. Connect. Router space OSPF and push 32. Network 20000. And now you provide IP address to the PCs. Now you configure first static NAT on this router. The syntax will be IP NAT inside source static, and then the pieces IP, that is 10.0.0.2, will be translated to the serial ports IP, that is 192.168.0.1, that is the direct translation. And now one more thing you need to do, you need to go to the Ethernet port and give this command IP NAT inside and to the serial IP NAT outside. Because you have to specify which interface is connected to the private network. Inside is the private network, and which interface is connected to the outside is the public network. And now you ping from the one PC to the other, say from 10.0.0.2, you ping the 20.0.0. Now it's pinging, and now let's go to the router and give show IP NAT translations. As you can see, the inside local, that is the private IP address of the inside network, that is the source network, that is translated to the inside global, that is the public IP on the source route interface, that is 192.168.0.1. So private to public. So that is the NAT translation. So that was the static NAT because we had only one PC. But if I add more pieces, say 2 or 3 pieces, then this NAT will not function. Then you should go for dynamic NAT or PAT. So let's add more pieces. So I'm disconnecting this connection and I'm taking a switch. And I'm adding another PC. It's 10.0.0.3. And now first remove the static NAT. So let me copy this line. So static NAT is removed, and now we create a dynamic NAT with NAT pool. So IP NAT pool, and you can give the pool name, say CCNE, and the public IP range. Let's say that is 192.168.0.10 to 192.168.0.11 because you are having 2 PCs. So it has 2 private IPs. So you should have at least 2 public addresses. And then the subnet mask, net mask, default one. And then you configure an ACL access list, say 1, and permit the LAN. And then the IP NAT inside source list, access number 1, then pool, and then the pool is CCN. So you are actually creating an access list because it is a network, it is more than one PC, and then you're attaching the source list as access list with the pool here. And you need to have the IP NAT inside and outside that is already there. So you just ping from these 2 pieces again. From this PC, pinging the 20.0.0.2, and now from this PC, from the new PC, you also ping the 20.0.0. So it's pinging, and now you check the router once again with the show IP NAT translations, and now you can see 10.0.0.2 that is translated to 192.168.10, and the 10.0.0.3, this one is translated to the 192.168.11. So this is a dynamic NAT that you have two public addresses and two private addresses are translated to the different two public addresses. So that is the dynamic NAT. And now I will change the dynamic NAT to port address translation or NAT overloading. So what I need to do, I need to go to the router 0, and now you need to go to this IP19 size source is run pool CCNA, copy this, paste it, and just give no, but it will say dynamic mapping use cannot remove. So what you need to do, can you copy this pool, but pool CCNA use cannot destroy. So what you need to do, actually you can try to actually go to this interface and IP inside, IP outside. So let me try, go to this interface, no IP NAT inside, and interface 250, no IP NAT outside. And now if I do this, yes, it is working. It is working as well. So now you need to create another pool, IP NAT pool, name the same name, CCNA, and here I am keeping only one public IP, say 192.168.0.12. That is the source, that is the means the starting IP, and that is the ending IP, 192.168.0.12. Then you need to give it twice, and net mask the same mask we are giving, because we are having only one public IP. And access is already there, so you just give IP NAT inside source list is number one, then pool CCNA, and then you have to use this word overload. So if you use this word overload, then it would specify it is a NAT overloading or the port address translation. If you do not use this word, this is dynamic NAT. That is the difference. And you go to the Ethernet port and you give again IP NAT inside and interface S250 serial port, specify IP NAT outside. And now you just ping from both these PCs again to the 20002. And now go to this router 0 and you see the translations, where you can see 10002 is translated to 192.168.0.12, as well as 10003 is translated to 192.168.0.12. So you can have multiple private IPs, but it is translated to the same public IP, 192.168.0.12, using the different source port numbers, as you see. So that is the port address translation or the NAT overloading. So that is about the NAT all we have, and I will see you in the next video.